Suppose I have a normal 0, 1 random variable. I choose n of them at random out of a big barrel. I square them and I add them up, and then I do it again. And I pick t of them out of this big barrel, square them, and add them up. And then I take the ratio of the first sum of squares and put it over the second sum of squares. What do I get? What? I can't hear the first one. I can hear the distribution part, but the air conditioning fan is right here over my head. We have sum of squared normals over sum of squared normals is... I thought I heard her, but it didn't quite register. I think maybe I'm trying to tell you something. How about f? The ratio of sum of squared normals to sum of squared normals is an f. How do we build a t distribution? This one's for Zen. Where's Zen Huang? There are two Huangs in here, by the way. How do you build a t distribution? What random variables do you need to do it? Students' t distribution. How do we out of what random variable should we construct? Students' t distribution. Did you ever use students' t distribution to test hypothesis? Oh. Why not? Didn't you have when you were in your basic statistics class, and you had a null and alternate like this, and you didn't know the population variance. Instead, you knew the sample variance, and you used S to estimate the population standard deviation. Did you have to do things like that in your beginning statistics class? And that had, let's call that T observed, and it's distributed as, this is distributed as a T. If I had n observations, how many degrees of freedom does this T have? N minus 1. And why did you lose a degree of freedom? Remember when I was talking to these other people about chi-squares and f's, the number of degrees of freedom corresponded to the number of terms in the sum. So S, as you well know, is the sum of the xi minus x bar, I equal 1 to n over n minus 1. Squared. Okay. We all do that. So previously, when we said we were using, we were talking about chi-squares, we said it was the number of degrees of freedom in the chi-square corresponded to the number of terms in the sum. Here I have n terms in the sum, but somebody just told me that the number of degrees of freedom in this t statistic is n minus 1. Why did I lose a degree of freedom? You're being too tricky for me. You're right, but the consequence of not knowing the actual variance caused me to use the sample variance. When I compute sigma, didn't I have over big N? Apart from the denominator, what's the difference between the two? Sample mean versus population. So didn't I have to go through the data once? Figure out the sample mean before I could say anything about the sample variance? So I went through the data once, get the sample mean, and then I computed the sample variance. So I lost the degree of freedom. Another way to look at it is, once I know the sample mean, if somebody told me the sample variance and I knew the sample mean, I can only choose n minus 1 of the x's. The other one will be determined, the last one will be determined by the first n minus 1. Given that I know s squared and x bar. So, the question was, And Zen is still struggling. Find me. So what random variables do I use to construct student t distribution? This student t distribution is the ratio of two things, something in the numerator and something in the denominator. Right? There's something, what do you suppose, what's the distribution of this? Under the radical, what's the distribution of this? These guys already told me, Nick and Lacey already told me what the distribution of this was. Chi-squared. So, therefore, what's the distribution of that part? Isn't this the sum of squared normal? Yes. So, by extension, wouldn't this be the sum of squared normal? The part under the radical. Yeah. So if the sum of squared normals 5 minutes ago was chi-squared, isn't the sum of squared normals chi-squared 5 minutes later? Yeah. So in the denominator, it looks like we have the square root of a chi-square. And previously, you guys had bought into the idea that x bar minus mu 0 over sigma divided by the square root of n. You bought into the idea that that was a normal 0, 1, right? So I'm always free to multiply through by 1. So why don't I multiply the numerator by 1 over sigma and the denominator by 1 over sigma? So then I have in the numerator something that's normal 0, 1. And in the denominator, I already decided that I had something that was the square root of a chi-square. Let's take 4 minutes, and pick up here. Okay. Well, I know that you had probability and statistics in the engineering program. I know you had to take, my kid is going, and he had to take probability and statistics as an undergraduate, not here, but somewhere else. Required class. All engineers have to take that, so I know that somewhere in your past it's and you certainly couldn't have done statistical mechanics unless you knew some of this.
Yeah, but again, you know, that's reliable, and then you don't really apply it all the time.
Okay. Let's continue on. T is the ratio of a normal to the square root of a chi-square. Yeah, perfect. Yes. Wrong. Yes.
In practice, how many times how often are you familiar with population variance?
Never. That's why we have t distribution. But they had to start somewhere in basic statistics. So you started off constructing z-scores. Right? And then you said things like, we don't know sigma squared, we're estimating it by s squared, etc. But we do know that the underlying distribution is normal. Therefore, the test distribution is still a t. And then you said things like, I don't know the underlying distribution, but I have a big sample. Therefore, I know that the sample is still t. If your sample is small, whatever that means, and you don't know the underlying distribution,